Now going further, let us study operations on sets. What are the operations that we can do on sets? The first operation we will study is intersection. First one, intersection of two sets. Now suppose you have a set A equal to 1, 2, 3, 4 and 5, and you have a set B equal to 3 and 4. Okay. Now A intersection, this is the intersection sign, B is equal to all the elements which are common in these two sets, that is 3, 4. So this is what you mean by intersection of two sets. And you can also show this intersection with the help of a Venn diagram. Like I can draw like this: 1, 2, 3, 4 and 5. Now 3 and 4 I will take it as my B, and this will be A. Okay, let us draw the diagram properly. Now this is your 1, 2, 3, say 4 and 5. Now here I will draw a circle, say this is B and this is my A. So this is how I can show intersection. Okay. Second way of showing the intersection is I will draw this as A and this as B. This is A and this is B, and we are having common is what? 3 and 4. Here 1, 2 and 5. Okay. So this is A intersection B. I'll take one more example, that is A is equal to 1, 2, 3, 4, 5 and B is equal to 4, 5, 6, 7. So here also A intersection B is equal to 4 and 5. Okay. Now using the Venn diagram, I can draw like this. 4 and 5 are common. So 1, 2, 3, this is A. 6 and 7, this is B. So this gives you an idea that A is a set which has 1, 2, 3, 4, 5. Take the full circle A. Okay, and B take the full circle, so 4, 5, 6, 7. And this part is nothing but your intersection part. This part, what you have is your intersection part. So what is written in this part? 4 and 5. So A intersection B is equal to 4, 5. Okay. Now let us see the properties of intersection of sets. If A and B are two sets, then A intersection B is equal to B intersection A. And if A intersection B is equal to B, means if you remove the common elements and all the elements are nothing but the set B, that means B is the subset of A. Then A intersection A dash. Now A is a set and A dash means A complement. So what is A complement? Whatever is not there in A. That means there will be nothing common in A and A dash. That is why A intersection A dash is 5, that is empty set. Now if A is subset of B, then A intersection B will be equal to A. And if A intersection B whole thing is a subset of A and A intersection B is a subset of B also, then what can you say? A and B are both equal sets. Actually, this is incomplete written in the textbook, so please complete this fourth one. A intersection B is subset of A, and A intersection B is also a subset of B. That means all the common elements are the A and all the common elements are the B. That means that A and B are two equal sets. So write down over there, they are equal sets. It is misprinting. Then A intersection A will be A itself. Okay? And A intersection phi will be phi. You take A and you take an empty set. What will be common in both? Nothing. So A intersection empty set will be again an empty set. Now let us see what do you mean by disjoint sets. D-I-S-J-O-I-N-T, disjoint sets. What do you mean by disjoint set? Now suppose A is equal to 1, 2, 3 and B is equal to 4, 5. Is there anything common in them? No. So they are said to be disjoint sets. So disjoint sets means which do not have anything in common. Their intersection will always be phi. Okay, they are said to be disjoint sets. Now let us take one example given in your book. 1, 2, 4, 7 and 5. Then we have 3 and 6 and a bit bigger. 3 and 6, 8, 9 and again we have one more, that is 10, 11, 12. 10, 11, 12 and this is C and this is A and this is B. Okay. Now tell which of these are disjoint sets. Which of these are disjoint sets? What can you tell about B and C? Do they have anything in common? Yes. 10, 11, 12 is there in B also, it is there in C also. Let us compare A and C. Yes, A and C nothing is common. So A and C are disjoint sets. A and B are also having 3 and 6 common. So only A and C are disjoint. A and C are disjoint sets. Okay. Now going further, let's see what do you mean by union of sets. Union of sets. Suppose A is a set 1, 2, 3, 4 and B is another set of 3, 4, 5 and 6. Then A union is written like this. B will be equal to all the elements of A plus all the elements of B. Only do no repetition allowed. So 1, 2, 3, 4, 5, 6. I have told you in the beginning also said that we don't repeat anything. Okay. So this is the meaning of A union B. Now how to draw the Venn diagram of this? Now we will draw like this. Take a bigger circle, name it as A. Okay. And 1, 2, 3, 4, 5, 6 and okay. 1, 2, 3, 4, 5 it was and this was 3, 4, 5, 6. So this is your B. This is how you show A union B. All the elements of A as well as all the elements of B are given in this. Okay. So disjoint sets and union of sets. Now let us see number of elements in a set. What do you mean by number of elements? Very simple. If A is given as 1, 2, 3, 4, 5 and 6. How many numbers are there elements? 6. So we will write like this. N of A is equal to 6. If B is an empty set, then N of B will be equal to 0. So number of a set means just count how many elements are there and write it. Okay. That's all. These are the basics. Now let us see the properties of union of sets. First of all, A union B is always equal to B union A. And A is subset of A union B. B is also subset of A union B. All the elements of A will be there in A union B. All the elements of B also will be in A union B. And A union A will always be A. And if A is subset of B, then A union B will be equal to B, because all the elements of A are there in B. So if you take the union, then that is nothing but your set B. A union A dash. A is a set and A dash means A complement, means whatever is not there in A. So whatever is there in A plus whatever is not there in A is equal to universal set. So A union A dash is universal. And A union empty set is A itself.